Now that we've been introduced to the idea of a quadratic graph and inverses, we're going to go ahead and look at what a square root function looks like. So we have discussed that a quadratic function, if you have something squared, the inverse operation would be using a square root. So let's go ahead and look at what the square root graph looks like. So the square root function, important features of it, is that it's going to have a starting point. So when we were doing domain and range, we would look at this starting point to determine what our domain should be and what our range should be. If you notice on the square root function, it's going to go forever in one direction, but not in both directions. It's always going to have a starting point. The other important feature of a square root function is not all of the x values are going to give you nice, pretty points. So when I am looking at nice points on a square root function, when I focus on the parent function, I would see 0, 0, because a square root of 0 would be 0. A square root of 1 would be 1. Now, if I tried to do what we typically do and find the square root of 2, it's going to be a decimal. And so square root of 2 is around a 1.4, but we don't want to graph that one since it's just not a clear point. So we would switch to 4 because the square root of 4 is 2. And then if I graphed the point at 9, the square root of 9 would be 3. Now, noticing on my parent function, the domain are all of my positive x values, including the 0, because if we take a square root of a negative number, we go to the imaginary number system, and we don't graph in the imaginary number system. So this is our real number graph of the square root of x. So in interval notation, that would look like 0 to infinity, with our closed bracket because it includes the 0, and the range would also go from 0 to infinity. Now, in order to get through this activity, I do want you guys to use Desmos. So a couple of important things here, and let me just close my parentheses. A couple of important things when you graph in Desmos, we are going to use the square root function, and so if you go and you hit the keyboard at the bottom, it will give you the square root right here. Another thing that hopefully we remember, because we just finished doing it, you could also say x to the 1/2. That's the same thing as the square root. And that is the family of functions that we are looking at graphing here. Okay. So what I want to do next is we're going to start making some changes to this. So if we went to Desmos and we typed in the square root of x, and notice where the 4 is. So if I type in a +4, I want to look and see what that changes about the function. So when I go to get my nice points, I see a nice point at -4, 0. I see another point here at -3, 1. If I keep moving, I see a point at 0, 2. And then over here, we have a point at 5, 3. So let's go ahead and graph those points that we just came up with. So we would have our point at -4, 0. We have a point at -3, 1. We have a point at 0, 2. And we had a point at 5, 3. So the general shape of a square root function is always going to look like this. We're always going to have a starting point, and then it's going to continue in one direction. This is my starting point, -4, 0. And here, I would now have to change my domain because it's not starting at 0, 0 anymore. It started at -4. So I would change this to be -4 to infinity. All right. And my range, though, if you notice, my y values have stayed the same. So I'm going to keep my range from 0 to infinity. Now, let's just take a quick glance and see what happens when I have a square root of x minus 2. So if I go back to Desmos, and instead of a +4, if I change that to a -2, now, instead of moving it to the left 4 units, it's moved it to the right 2 units. So I'm going to have a point at 2, 0. I would have a point at 3, 1. I would have another nice point here at 6, 2. And then if I kept looking, I see another point here at 11, 3. So let's go ahead and plot those points also and talk about the effect that this change has. So this was over at 2, 0, and all of these points are coming from Desmos for the time being. And then if I was at, we said 11, 3 was one of my points, and 6, 2 was another one. So if I go ahead and I draw this graph in, notice we have our starting point, but it is now over at 2, 0. And so if I draw my square root function, it's going to continue forever in that direction. My domain is now going from 2 until infinity, and my range stayed at 0. So let's go ahead and draw some conclusions here. What effect did the plus 4, so in this case, the plus 4 have on the graph when compared to the parent function? So we have actually done this before with quadratics. I have a number in with the x. The plus 4 actually moved my function to the left 4 units. All right. This also changed my domain, right? Whereas when I had an x minus 2, it moved it to the right 2 units. When we looked at the ranges, the range from our parent function actually stayed the same. So there was no change to the range. So if you guys remember, when we did vertex form of a parabola, we talked about anytime a number is inside with the x, or in the operation with the x as we see here, it's going to do the opposite. We would say, in this case, insiders lie. So an x plus 4, instead of moving it to plus 4, it actually moves it to minus 4. Instead of a minus 2 moving it over to negative 2, it moved it to plus 2. So the same concept that we had studied in quadratics, where when we did our vertex form, and I'm just going to write it out here so you guys can hopefully remember, and we would say x minus h squared plus k. This h we always did the opposite with. So if it said x minus 2, that meant to the right 2. If it said x plus 4, we would move it to the left 4. This is the same concept here. It's just now with a square root function as our parent function instead. So now what I would like you guys to do is continue through the rest of this. I want you to graph a square root of x plus 4. One last comment before you guys take off on your own. Notice the square root function stops there. So I want it to look like this, square root of x plus 4. Be very careful that when it doesn't have the line over it, you actually stop the square root. And so what you're going to be looking at here is a movement up and down. So get some nice points to graph both of these and answer the questions, and just continue through the exploration.